right, if you made it this far, you made it to Unit 10, which is the last unit of Blended Algebra 2. So you can do it. One more unit, and it's almost all factoring. You've been factoring for years. This should be pretty easy to finish with. So the first thing is we're going to solve polynomials, not just quadratics anymore, but higher order polynomials. So degree 3, degree 4, degree 5. How do we solve a quadratic? Let's go back to the beginning. Well, back in, I think it was Unit 3 or 4 of this course, to solve quadratics, we could factor. That was a good way, and that's what we're going to do a lot of here. We could solve by graphing, so we would type the equation into our calculator or Desmos, see where we cross the x-axis. We could use the quadratic formula, which we're going to use again here today. Or we could solve by completing the square, which we might also use again. Okay, so I have those 4 methods. Now, how do I use those to solve? Let's review. Let's recall that polynomials of degree 2 are called quadratics, and degree 2 polynomials have 2 solutions or 2 roots. We learned that in Unit 9. When I have a polynomial, the degree is equal to the number of roots or solutions. So let's solve by factoring. The first one, x squared minus 49. I solve that by difference of squares. There's 2 terms, there's no GCF, so I take the square root of each term. Square root of x squared is x, and the square root of 49 is 7. I take the opposites, I do 2 different signs here, a positive and a negative. Now in order to solve this, I set each factor equal to 0, and I solve. So the left factor, when I subtract, I get a root at negative 7, and the right factor I add, and get a root at positive 7. That should be pretty simple, pretty easy. You should feel confident about solving by difference of squares. Let's try question B. 8n squared plus 24. Well, there's 2 terms again, but I can't take the square root of them. Remember, when you're factoring, the first thing you do is you always look for a greatest common factor. And here, both terms have an 8, so I'm going to divide that out. And they also both have an n. So I'm going to pull an 8n out in front. And then within the parentheses, when I divide 8n squared divided by 8n, I'm left with 1n plus 3. That's my factored form, so I set each of those factors equal to 0, and then solve. First one, I'm going to divide by 8, and get n equals 0. And the next one, I subtract 3, and get a root at negative 3. And those are your 2 solutions for that quadratic. So different difference of squares, GCF. The third problem here is a trinomial, and the way we factor trinomials is by splitting the middle. I'm going to multiply the 4 and negative 3 together to get negative 12. I need to find 2 numbers that multiply to negative 12 and add to negative 1. That's going to be negative 4 and 3. When I split the middle here, I put the negative 4 inside plus 3x. Now use x because the middle term is an x. And then minus 3 on the end. You go ahead through and you use the method of grouping. You pull out a GCF. The first group's GCF is a 4x, so you'll be left with x minus 1. The second group's GCF, it's positive, so I'm going to pull out a positive 3, x minus 1. And then your factored form takes the GCFs in front, 4x plus 3 times x minus 1. Now in order to solve, you set each factor again, equal to 0. The right one's short. I go ahead and add 1, and I get a root at positive 1. The next one here, I have to subtract 3 first. So I get 4x equals negative 3, and then divide by 4. So my root is going to be at negative 3 over 4. That should be a review. Going through that pretty quickly shouldn't be too bad because you've seen all of that before. Now let's try 4 problems where we now are taking the same techniques to solve higher order polynomials. We're going to start with cubic polynomials. That degree is 3 of a cubic polynomial, so there's always going to be 3 solutions. So let's combine all of our factoring methods. I have x cubed minus 3x squared minus 4x. Well, it is a trinomial, but there's something that I should notice first. There's a GCF. Each one of these terms has an x in it. So to divide x out of every term, I'll have x times x squared minus 3x minus 4. Now, what I do is I have to factor the trinomial inside, and I'm going to do that by splitting the middle. So I'm going to leave the x in front, and I'm going to find two numbers here that multiply to negative 4 and add to negative 3, which will be negative 4 and positive 1. So I split the middle, x squared minus 4x plus 1x minus 4. I pull out a GCF here. I'm going to leave my brackets. The first GCF, when I group these, will be x, so I'll have x minus 4. The second group will have a GCF of 1. And now I can see what my factored form is going to be. I have an x plus 1, an x minus 4, and then the x comes down. That's my factored form. And from there, I use the zero product law, set each of those factors equal to 0, and solve. X equals 0, that's done for you. If I subtract 1, I get a root at negative 1. And over here, I get a root at positive 4. So I have a cubic with 3 solutions. All right, now the next one. Every problem we've done so far has had real, rational roots. Letter B here is going to be a little bit different. First of all, I notice there are 4 terms, which means I'm going to factor by the method of grouping. So I pull out a GCF. The first GCF is x squared. I'm left in parentheses with x minus 5. And the second GCF here is a positive 3 to the left with x minus 5. Now that's good because the x minus 5s are the same. So I factored form of x squared plus 3 and x minus 5. Now I'm not fully factored yet. I want to look at the left-hand guy. Has an x squared, but it's a plus and a 3. Neither of those allow me to use difference of squares. So where I'm going to go from here is I'm going to set each factor equal to 0. I'm going to go ahead and use the zero product law. The right one makes things easy. I just add 5, and I get a root at positive 5. The left one I have to do a little bit more work. I'm going to start by subtracting 3 and get x squared equals negative 3. Now I have to get rid of this square, so I'm going to square root both sides. Now you need to remember, when we square root something, we have to put a plus or a minus in front. I also have the square root of a negative number, which means I'm going to pull an I out and leave the radical 3. So this root, there are 2 roots here. The roots here are 5, positive I radical 3, and negative I radical 3. There are 2 of them in there. So you have all 3 roots that you need, but those are irrational and imaginary roots. 2 more problems to try. The third one, letter C. All right, same thing as the first one here. I'm going to pull out a GCF. This GCF this time is actually 2x. All these numbers are even and they all have an x. So I'm going to pull a 2x out in front, and I will have x squared plus 5x plus 6. I'm going to go ahead now and split the middle, just like I did back in question A. I need 2 numbers that multiply to 6 and add to 5. That would be 2 and 3. I'm going to go ahead and group. The first 2 here have a GCF of x. Put my brackets again. So I'm going to pull out an x, and I'll be left with x plus 2. The second group here has a GCF of 3, and I have x plus 2. You should see then, when you write your factored form, you have the 2x, x plus 3, x plus 2. And you can go ahead and set each factor equal to 0, and go ahead and solve for x. The first one I have to divide by 2 right now, but that still gives me a root of 0. Here I subtract 3, and I get a root of negative 3. And finally I subtract 2, I get the last root of negative 2. And that'll be your factored form. Now D is a little bit more complicated. You factored like this during regular algebra 2 during the school year, but not yet in the blended class. X cubed, 8x cubed plus 27. This guy uses an acronym called SOAP. You probably did this in class. The acronym SOAP. I will get back to you in a couple minutes. But that's the SOAP method, a lot of people like to call this. Now, in order to factor this, you're going to have two sets of parentheses. You're going to have a short set of parentheses that has 2 blanks in it that you're filling in, and a long set of parentheses with 3 blanks. In order to fill in the blanks, you have to take the cubed roots of each of the original terms. So the first blank here, I take the cubed root of 8x cubed. That would be 2x. That goes on my first blank. The second blank takes the cubed root of 27, which is 3. Don't put any sign in the middle yet. We'll get to that, but I have a 2x and a 3. Now let's fill in the other set of parentheses. The first blank takes the 2x and squares it. So 2 squared is 4, x squared is x squared. Excuse me. The last blank takes the 3 and squares it. Now the middle blank multiplies the 2x and the 3 together. 2x times 3 is 6x. So now here's where SOAP comes in. SOAP stands for same, opposite, always, positive. Now what that stands for is the signs. You're going to put signs, plus or minus signs, in between all the terms. And it's going to be based off of the original sign, which here is positive. So the same sign as that is positive. So that's why we're going to put a plus for same. The opposite of plus is a minus, always positive. Now that's your factored form. That in itself can be a little bit challenging, but now we have to solve it. So what I do is I'm going to take the 2x plus 3 and set it equal to 0. We'll talk about the next part in a minute. I'm going to subtract 3 and get 2x equals negative 3 and divide by 2. That would be your factored form, or your solution for that first factor. Now the second guy is a trinomial. You can try to factor it if you want. You need 2 numbers that multiply to 4 times 9, which is 36, and add to negative 6. Well, here's my factors of 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. None of those are going to add up to negative 6 at all, even if I make some of them negative. So this guy doesn't factor. And in fact, any time you use SOAP method to factor, it is never going, that trinomial is never going to factor, ever. Don't even try. Don't waste your time. So in order to solve this, you need to use the quadratic formula, which is why that's up here in the box. So to use the quadratic formula, you need to know your A. A is the first number. B is the second number. C is the constant. X equals, now the formula says the opposite of B. Here B is negative 6, so the opposite of that is 6, plus or minus 1 long square root. Under the square root, I take B in parentheses squared minus 4 times A times C, all over 2A. Now you're going to need a calculator here to simplify. X equals 6 plus or minus. So do not type the square root into decimals. Just type what's under the square root into decimals. So what I would type in is negative 6 squared minus 4 times 4 times my C of 9. That gives me a value of negative 108. So that stays under the radical. Don't type the radical in yet. All over 8. Now, square root of 108. I have to simplify that if I can. It's negative, so I'm going to have an I. So when I rewrite this, I'll have 6 plus or minus something with an I, and then a radical. I need to figure out what that is. So break down negative 108, or positive 108, I guess, into perfect squares. Let's take our calculator. 108, let's see, if I divide it by 64, let's see, that doesn't work. If I divide it by 36, oh, that works, 36 and 3. 36 is a perfect square, so I'd have Radical third is 6 times radical 3, which is 6 radical 3. So when I rewrite this, I'll have 6i radical 3 all over 8. Now, if you left that as your final answer, that's fine. However, know that you can simplify that because the 6 and the 8 are all even. So you could divide those numbers by 2 and make it 3 plus or minus 3i radical 3 over 4. That's more complicated. If you can get to the part without dividing the fractions, that's okay. All right, then I at least know that you know what you're doing. All right, that's the notes. That was the last hard one to end on. Try a little bit of the practice, and we'll move on to part 2. There's only 2 parts in the whole unit.